Hello everyone, I'm Xiaogang. Okay, in this lesson, I'll talk about the architecture of this plugin. The architecture of this plugin is really complex, basically more complex than the architecture of the previous 30 chapters, because we wrote it in a very convoluted way. Actually, it kind of feels like an engine. Let me explain why it's so convoluted. Actually, in the Build.cs file, you'll find that, in fact, this thing mainly includes car. We didn't include the engine module. But there might be some extra modules here. Let's ignore that for now. We want this plugin to be usable in a standalone program. But I haven't done that work yet. Right, and the modules here might need some modifications later. Let's ignore those for now. This socket is the module we need to use for those 3 socket modules. It might be in here. Yeah, that is our builders. And we actually don't have many files. The files are still our usual plugin architecture. There is this AssetAction, and the point we need to pay attention to is this AssetAction. It does not inherit from the blueprint in our engine. We have it inherit a smart pointer, right? Then we inherit the smart pointer. And the writing style here is actually, it looks similar on the surface, but the difference is actually quite significant. You have these methods bound, and these methods need to be bound to our socket. Because our socket is also opened on another thread, then we will inevitably have something like this runnable to handle this actual thread. And this thread needs to be responsible for this TCP communication. This communication definitely cannot be placed on the main thread, otherwise it would block the main thread. So we created a thread here, and this side mainly handles some TCP related work. You can see there is quite a bit of code here, close to about 300 lines. Yeah, and then in this section, it is actually close to 500 lines of code, right? Okay, next as for these word vowels, there's nothing much to say. Instead, it's about the subsystem, because we don't want the concurrency to be too high. Sometimes we might want to control it. They can turn to at the same time. But it seems this subsystem doesn't implement concurrency control. We should have had a queue. That is, you submit a task, and then we process one per frame, or every few seconds. Here, there is a singleton. This system singleton manages all of our side actions. Because through it, we can the current action and which state it is in, right? And whether it has ended or whether its machine has already completed. So this singleton mainly takes on such a role. And for this singleton, we also use the C++ style of writing. You see here, and we have a type here. Obviously, this type is what we see in the blueprint, the information our users need to pass. And then we have a toStream. We actually just convert it into the data format we need. And that's it. Then this state appears on it. In fact, this state corresponds to the state we talked about in the previous lesson. But later we will also add some other states. The first field and the last field are our reserved fields. An error occurred. We have some initialization processes of our own. Then we enter the corresponding stage. And sometimes when we troubleshoot errors, we need to expose the errors of the corresponding stage. And basically, this is equivalent to the file. This is the definition of our entire data structure. And this subsystem is for managing our entire singleton. As for this BP library, you can see that here it queries the specified action, removes a certain action, or releases it, or gets all the current pending actions. Right, because on the server, you might need such an interface. Then the complex part is that here, we need to interact with this AssetAction. We interact with this runnable. To interact, we previously did Wediot. When doing the Yacht server, it was actually the engine's underlying layer. They helped us encapsulate it. A proxy similar to this. You see, we are passing a reference like this. So this reference is actually attached here. That's how it's done. So now we need to create a similar reference relationship ourselves. But in the future, because in Unreal Engine, when you use TCP UDP, you better not call it directly in the native way, a kind of C++ underlying layer, this kind of Windows approach, providing it because sometimes cross-platform may be needed or other such features. So when we call it, actually, in the process of this call, we actually need to use this. The engine provides this way of creating TCP. Such methods, then through the engine's parameters, we complete this related work, right? You see, this TCP UD, we mainly use these modules to do it. This way, we can take advantage of the engine and the benefits it encapsulates for us. Okay, so that's actually it for the plugin architecture. That's all I have to share with you. Then in the next lesson, we'll start going through it step by step and write the code from top to bottom. Okay, thank you everyone.